And the back end for this platform wasn't that big when it started out. So if somebody wanted to do something similar here in their country, a TV card, encoding some TV channels, saving the programs, making them available on a website, but then only having that content available to users who are picking up the traffic locally, could be a big incentive for people to connect to internet exchanges, increase local interconnection, and drive local content. So that's all from me. So in conclusion, there's unfortunately little locally hosted content in Africa at the moment. We saw that at the start of the presentation. But increasing content hosting will help to increase local interconnectivity and peering and reduce that dependence on those international links that cost so much money. And you can achieve this by developing local content hosting services and also by distributing global content through CDNs and caching. And then encouraging the use of that local content rather than content hosted outside the country, outside the region, can help create a virtuous circle to help drive this higher. So that's all from me. Any questions? So in terms of the distinguished ISP thing, we try very hard to work, so I say Google try very hard to work with all operators equally, and so we don't want to deploy one of these with one particular ISP if it means they get an unfair advantage over other ISPs who don't have it for whatever reason. So this is why in most countries in Africa where there's very low volumes of traffic, we ask the ISPs to share this cache with other operators so everyone has equal access to it. In terms of the sharing of the international bandwidth cost, at the moment, unfortunately, we can't afford to do that with a cache. What we do is when we build out our network itself to particular cities, then we do pay for the international bandwidth. So we build our network, and we've done this to Lagos, and we're doing it to Mombasa later this year. So we buy international capacity to come to a particular city. So in Lagos, we are peering with local operators in Lagos and delivering traffic to them locally. Exactly what traffic we can deliver sometimes depends on the cost of bandwidth, because YouTube uses a lot of bandwidth, it doesn't make too much money at the moment, so sometimes we can't deliver video on there straight away. But as the cost of bandwidth comes down, that will change, and we will be able to deliver more traffic locally in more places to more users. Okay, so in terms of the caching services, you wouldn't put one behind the other. You'd probably only choose one of Squid, Bluecoat, or like the Neo or Gcache, which I think. But then you could put, say, a Google cache next to a Bluecoat cache, and not put Google and YouTube through the Bluecoat, but put it through the Google cache instead, which is optimized for that particular content. Of course, it's better if you don't have to have caching at all, because the cost of the international bandwidth is low enough that it's not an issue. But we live in a realistic world where we have to deal with the practicalities, and sometimes you have to have these things to help reduce the traffic on the international or long-haul traffic on your network to a reasonable level. I think it's harder to get other people to come, but I think the fact that Google is already here in 15 or so countries in Africa is a good kind of incentive and a reason. It shows that it is possible to do this. It is possible to make a difference and improve the performance for the local users. And the fact that Google has done it, and we're an American company run by American lawyers, and the lawyers don't do anything unless they're very certain that it's not going to be a problem. So the fact that encourage other companies to say, okay, well, if they've done it and their lawyers think it's okay, then it's probably okay for it. Lawyers are they're like a pack animals. They all move together. So if you can persuade one to do it, you can probably persuade more than one to do it. And I've had some informal discussions with Akamai, and I'm trying to encourage them to come to some of the same places that we are. The internet is a fantastic thing, and it doesn't matter where content is hosted. It's available universally anywhere on the internet. There are certain performance benefits for having the content in a certain location, and so for guys in Tanzania, there's definitely a performance benefit for having your content hosted in Tanzania. But even if it's hosted in Tanzania, it doesn't mean it's not available to people outside. And because most of the traffic on the submarine cables coming to Tanzania is from Europe down to Tanzania, there's a big, wide open, empty motorway, effectively, available to send the traffic from Tanzania back out to the world. So hosting content here that's relevant for the whole world is certainly possible. I mean, there's a small latency delay and so on, but if it's mostly relevant for an audience here, it's definitely better to host it here. So yeah, so the marginal cost of sending a high definition video from Tanzania to London is basically zero for most people because they have the spare bandwidth available anyway, up to a point until you start sending more than you're receiving. But certainly to start off with, there's virtually no cost in doing it. Any other questions? Okay, thank you very much for your time, guys. I'm on a bit later as well, so you got double dose of me this afternoon.
Okay. Next, we have Michelle Opio from Kennet to present on NREN best practices.
My name is Michelle Opio. I'm from Kennet Education Network. It's National Education and Research Networking. I'm going to begin my slides with the diagram of our network and the peerings that we have. We have our core routers, which are connected to UbuntuNet, and we have 155 MB uplink, CCOM, and 622 MB on Teams. We also have a peering with ixps, which we use to keep our local traffic local, and we have peering with the institutions that we serve peer with our POP routers as well, which peer with our core routers. The ixp bandwidth is to be upgraded to 1 gigabit from 100 Mbps due to the introduction of the Google Cache in ixp. So the links to the institutions are mostly on... Are you getting me? Can you hear me? Yeah, okay. The links to the institutions are mostly on fiber, but some of them, which are deeply situated in the rural areas, have radios connected to them. Our routers, we have private AS numbers to our clients, so we use internal BG within our network, and as we go out, we strip out the private AS numbers and send out our public AS number, which is 36914. We use the loopback IP addresses in order to keep, to allow for dynamic routing. If one route to the institution is down, you can use the other route and be able to still get the institution. We use authentication for our servers and our routers using AAA and TACA. That's for our security, and to keep some of the network engineers from the institutions from changing the routing or making other changes that could result in loops or otherwise break our network. The router configurations are also backed up in Rancid so that we can go back or roll over to the previous configurations should anything go wrong. Our external peering is to UbuntuNet, which also serves as our transit. UbuntuNet focuses on education and research traffic, so they're able to load balance our links in a ratio of 4:1 in favor of the STM4. We also have KXP pairing with our POP routers because of the multiple connections to the internet, and that allows us to, like I said, dynamically change the routing. We found that peering with KXP has been particularly useful, especially with the introduction of the Google Cache there. And a lot of the traffic from educational institutions is to mostly Facebook and Google. So we have benefited from that and are able to keep up to 40 Mbps locally instead of going out to get it from the internet. We also have introducing 2 NOCs in our network, one at our office in Nairobi University and the other one at International University, USIU. Mostly to monitor our network with the various services that we have and that we are implementing. We use various tools. We have Cacti, which we use to monitor the utilization of the bandwidth. We get to know exactly who is using what, and it enables us to distribute the bandwidth evenly to everyone according to how much they pay and how much they use. We also have NFSEN, which we use for the net flow data. It's particularly useful in analyzing who is using what traffic, where are they going, especially coupled with a few other tools that I'll show you later that can show you where you need to get transit, where you need to peer, or who you would like to select as your carriers. We use Xenos to monitor our servers. It gives us information about what protocols are in use, if the services are running properly, and a whole bunch of other things. It also alerts you if you have any issues with your servers. We use OpenNMS as well. It has a ticketing system. It's very powerful, and you can customize it to suit your needs, especially when you're running a big network. We have NetDot that is useful for documenting your network. It is able to collect data, and it can even draw for you a picture of your network if you tell it what IPs you have in your network. It can generate a network diagram for you, and it assists you in keeping tabs on your network. You'd be able to know if someone introduces something. For our ticketing, we use RT, which is useful. You can also automate it in order to keep yourself from having to manually update the tickets constantly. This graph is an indication of how the traffic went up after the introduction of the Google Cache at KIXP. Samia is one of our core routers, which is connected. So as you can see, before the introduction of the Google Cache, there was only about 15 Mbps traffic at KIXP, which went up to about 100 Mbps, which has filled our pipe, and as a result, we'll have to upgrade the link to about 1 gigabit. The NFSEN, which is a tool that we are using to analyze our traffic, keeps track of all the ISPs which have peered at KIXP, and it enables you to know which peering is beneficial to you. You can also track your traffic by the AS numbers, and it's relatively easy to configure. We use it on FreeBSD in Kenneth. Yeah, and it also allows you to create custom graphs to show you exactly what you want to see in your network, and based on that, you can make decisions on how to peer and etc. Okay, this graph isn't really clear. It has Facebook traffic as well as Google traffic. The Google traffic is going to about 40 Mbps. You're able to track whatever traffic you have at your exchange point or wherever you place the net flow, and show you exactly how much traffic is going to which